Hello everyone, my name is Antonio. I'm a software engineer in EngFlow, and this is my first tech talk, by the way, so please be kind. Thank you. Please be kind, because otherwise I'm a big guy and I'll find you. Yeah? I really want to talk about how to make Bazel faster. We all know that Bazel is supposed to be two things, which are?
Fast.
And?
Correct.
Nice. Well done. You've done your homeworks. And Bazel does plenty of things to ensure that it is correct. But fast is not a guarantee. Like fast, you gotta work for it. Correct now. Correct's perfect. Unless you really try to break it, in which case you can even end up running Snake on Bazel, which someone did. Definitely don't check out my GitHub account, which is at the Grizzly Dev, mostly because of the resemblance. Or you can also contact me by antonio@engflow.com, or just reach out on Bazel Slack. Sometimes I might even reply. Well, first of all, before I start, there's two things I want to address. First, I want this talk to be extremely interactive. Ask any question, except you, Yannick, if you're somewhere. Please don't ask questions. Don't. So interrupt me as much as you want, like with some reasonable limits. But why would you make Bazel fast? You must have some answers. Why would you make Bazel fast?
You caught me by surprise.
That's what I wanted.
Why are you making, sorry?
Why would you make a build fast?
Why I want to speed up? Because I want faster CI pipelines. I want fast build durations. I wanted our developers to be happy, and I want a better experience for the company.
I just asked at one point. You gave all of them.
I threw everything that I did.
You ruined my gig. Any other answer?
Cost.
Cost. Yeah, Tom, I knew you were going to say cost. Any other answer? No?
To keep lazy developer to be in the company.
That's a good answer, but evil. I like it.
I don't want to get older waiting for my build.
Yes. Turn around. He used to have really long hair before he started building code. And that's why I joined EngFlow. He wanted to make things faster. Now, faster CI jobs can save money. More productive and happier developers. We're relatively happy, we're still developers. And quick release cycles and dot fixes. Now, there's something that Helen said during her talk, which I really liked. She said, in every big company, there is always a Bazel developer lurking in the corner. Now, I want you to leave that dark corner, stop hissing at your manager, and promote Bazel. It's actually not as hard as they say. It can be extremely productive, it can be extremely fast, and it can be relatively fun. Let's not exaggerate too much. So now that we know why we should speed up a build, I want to introduce two mnemonic devices. I'm going to be giving lots of tips and tricks, maybe too many of them, and some best practices on how to make builds faster. Some of them even apply outside of Bazel, but I'm not going to say that because I want you all to use Bazel. And so these two devices are Coyote, which is representative of complexity. You've all seen this cartoon as a child. And zero coyotes is really easy, trivial. 4 coyotes, really hard. Anything in between, you can probably guess. And for the speed up, we're going to use the Roadrunner. So each slide is going to have a Coyote score and the Roadrunner score. No Roadrunners, really slow. Barely any improvements. 4 Roadrunners, much faster. Almost as much as running EngFlow in production in 1 month. So my first tip is extremely trivial. Keep Bazel warm. Now, what do I mean by that? Just leave it outside in Israel. Definitely warm. Don't go to Iceland. Oh, I know, we should. Sorry, man. Bazel runs, every time you run Bazel, you're basically running 2 processes. One, which is a CLI written in C++, right? And the other is a daemon written in Java that is running for a very long time for multiple builds, and it's only closed when you change version or you change some other constraints. And the C++ part is really fast. It's supposed to start really fast and die really fast after a build. But the daemon stays there and caches things in memory. Now, why is that important? If you have a really, really large code base, Bazel, before it starts, it has to analyze a bunch of things. And so keeping that cache hot in memory helps making things much, much faster, because it doesn't have to go through the whole build again. Not the whole build, just a part of it, the one that changed. So the most trivial suggestion is just ensure that Bazel keeps running, and they will do some magic for you.
Is that a local cache or central cache?
Well, actually, this is, I'm just referring to the memory cache. Bazel has a bunch of caches,
Okay.
and this talk only lasts 1 hour.
Is that a C cache implementation?
No, there's none. It's just a simple in-memory cache in this case we're referring to.
So per developer?
Per developer, unless you...
Per workspace even. It's like per
Per workspace, exactly. Exactly.
Per developer?
Per developer, per instance, per workspace, this is going to be different. And so it becomes a bit more contrived to do this in CI. I won't go into details, because that would be a whole different talk. There's a few very interesting blog posts on how to run Bazel in CI. That you can find in the wild. I don't remember who made them, but you can Google it. It's very, very interesting, but it's a bit hard. Hence why we gave it the 3 coyotes. But it can make things much, much faster. And now let's get into the other kinds of caches. Bazel has something called action cache, which keeps the results of an action execution somewhere, which could be remotely, on disk, on paper, maybe, I don't know. And of course, as any cache does, it uses some keys. Now, actions are basically how Bazel executes things from some inputs and gives you some outputs. And to do that, you can think of a few things that would go into the scheme. You would have the command, you would have the input paths, the digest of the inputs, remember those, and the environment properties. So if you have environment properties, which are often changing, like a timestamp, for example, just to cite one, your action cache is always going to be invalidated, because every time you run it, the action key is different. So when you're running Bazel, it's really, really important that you're in control of the action environment. So all the environment properties that go into action execution. Because if you're not in control and you have ephemeral values in every single build, then your action cache is never going to work. You're going to run everything. I went too far. But also, get rid of unused dependencies. There is no easier way to do less work than doing less work. As simple as that. And not just that, but getting rid of unused dependencies sometimes simplifies the build tree, and some things may be able to be executed in parallel much sooner than they would otherwise. Right? And this could be a very tedious task, but thanks to my beloved colleague Jay, it might be much, much easier with Bazel. So Bazel is a build file generator, but you can also use it to trim unused dependencies. So what this tool does is it reads the source files, because for each one of them, and either generates build files or corrects them. Now that is a mechanism that can be used to remove unused dependencies in your build files. And they're always up to date, because they're based on the source code itself. It works brilliantly in Go. There are some extensions for different languages like Java, and I don't know, mostly Go. So use Go. Lovely language. Any question? All right. Sometimes though, the problem is not that you're doing too many things, but you're doing too few things. As in, you're trying to build 500 files in one go. Now, there's no way Bazel can parallelize that, because that's always one action. So in some ways, you have to have Bazel help you. And one way of doing that is to break down bottleneck targets. So let's say that your build only has 3 targets. Each one of them is 500 files. The first depends on the other 2. Your build is going to be 3-step. Slow, slow, slower. And that's not what we want, because the parallelism of that is at best 2 threads. But if you have 1,500 files, you can probably go much faster than that. So if you were to break down those into various targets and control well how they depend on each other, well, you can end up parallelizing that to hundreds of different threads, even more, maybe even running on remote execution EngFlow. And that, of course, leads to faster builds. But not only that, when you invalidate one of those files by changing the source code, you're not going to have to rebuild 500 files, but way less, right? And of course, you also have easier cache hits this way, more cache hits rather than easier.
Antonio?
Yes.
Is there a price for more small targets in comparison to one big target?
Yes. Yes. Sometimes you do have a price. Let's say that you're running a tool that starts really slowly, and instead of running it one time, you run it a bunch of times. You're going to pay that startup price many more times. Now, yeah, it's looking at me. The Google guy's looking at me. There are ways to fix that, but eventually you might have to pay that price. Later on, I'm going to present one of the ways that Bazel addresses this problem, which is called persistent workers. But you might have to pay that price too often, and so the trade-off might not be there. We have an example of that in our own build where we have this problem with TypeScript. We went too granular, and now we're just paying the price of TypeScript, taking forever to run. If we had a single bigger target, it would probably be faster. Now, you don't have to go through the 2 extremes. You can stop somewhere in the middle. And when you're doing that, the best suggestion that I can give you is experiment and get a profile and measure your results. Always measure the results. So when working on speed improvements, the most important thing is to measure improvements. The easiest way is grab a profile, which Bazel generates for you, and either run it through a UI we have yet to talk about, which is really cool, or just upload it on Chrome tracing and visualize it, see how much better things are, and keep iterating over it, step by step, until you get the desirable result that is hopefully also maintainable. So if you break it down too much, another cost that you're gonna pay is the cost of maintainability, right? It's gonna be easier to maintain that build. Now it's much easier if you're using tools like Bazel that do it for you, but when you don't have that, you want to find the right balance, right? Good question.
There's another price that you might pay in terms of memory on the Bazel server side. The more targets, the more actions you have cached in memory, the more memory is retained, which might be a problem for you on the laptop, might not be on a larger desktop machine.
Or on remote, yeah. Or on a CI, really. So yeah, good point. Questions? No. Now, you hinted at this. Breaking down actions too much, you hinted at this problem of having actions that are basically doing a lot of busy work initially, like starting the JVM, and then the actual execution of the action is minimal when compared to that. And all that busy work you really don't need. Unless you want to get a coffee. In that case, maybe you want it. A solution that gets around this problem is persistent workers. So Bazel allows rules author to write actions in a way that they use something that is more akin to a daemon rather than a CLI execution. And that is called the persistent worker protocol, which is this IPC protocol that will first start your process and then will execute calls to run that action on that daemon process rather than on an ephemeral process. There's also a spin on this that we implement, which is called remote persistent workers, which does the same thing, but remotely, where you have even more resources. Right? So you can get the same benefits with the benefits of scaling up to hundreds of jobs at the same time. Now this is a very cool feature that Bazel has, and it's implemented and enabled by default on Java. It's also implemented by Rules Kotlin and Rules Scala, but you have to enable it yourself. And it makes builds much, much, much faster. It's one of those things that we have seen brings the biggest improvement to builds.
And it's available from Bazel 6.
No, persistent workers is from
Persistent
Bazel
workers
1.
is an ancient feature. Remote persistent workers had some problems before Bazel 6, which we can elaborate on because I don't remember it. Thank you, Yannick. See, you can't ask questions, but you can answer them. Well done. And so, well, if you want to use remote persistent workers, then we suggest using Bazel 6 rather than a patched up version of it. Unless you really want to.
Would these remote persistent workers, would that be the recommended setup if your development environment is remote as well, like code spaces?
Yeah, but you have to use EngFlow for that.
Fair enough.
You're welcome. Any other question? All right. On to my favorite part, the one that pays my salary. Consider using remote execution and caching. I think it's pretty obvious why this is so good, right? Your meager little machine can have like 8, 16, 32. Definitely less if you have Mac, of course. And you can run a bunch of things in parallel. But on remote execution, we can run a few hundreds of things in parallel. And that's why companies like Wix are adopting it. Because at some point, builds grow unmanageable for a single machine, no matter how powerful it is. Even if it's a Graviton on AWS, it's not going to be fast enough. Right? You want to distribute that build to a different level, where you're thinking about hundreds of jobs, where you're thinking about sharing cache sheets between CI, interactive users, and so on, between various runs, right? And that is where remote execution and remote caching come in play. That is what we do, what we provide as EngFlow. So forgive me, I'm gonna be a bit biased. I think you already got that from the previous slides. But this is one of the, if not, the biggest speed improvement you can get. Now, it also gets two coyotes because it's not trivial, as someone's proven in his previous presentation. And it does require some effort on both ends to come up with the right dimensions for the cluster, figure out what is the type of workloads you have. It's definitely the one thing that is gonna make you, that is gonna give you the biggest bang for your buck. Unless you want to completely delete the repo, in which case the build is gonna be extremely fast, instant. So we do not suggest doing that. Questions? Good, good. Initially, I've talked about Bazel's correctness, and I can't stress it enough. Because Bazel is correct, you can do one of those things that you cannot do in any other build system. Not running build system clean, right? How many times have you used Maven, and you've had to run Maven clean? Every 5 minutes, twice. And realize that your artifacts were still wrong, right?
Of course, you nuke the M2. RM
Always, RM.ref or mem2, always, man. Except when there are some weird setups, in which case that might not be even possible. And that kind of applies to most build systems. I kid you not. The best thing that Bazel does is disable this. No, it does not disable it, of course, but make it as something that you're not going to have to use too often. Now, there are some catches. If you have Mac, well, ditch it. But when you upgrade, you're usually going to end up with a broken setup for Xcode, in which case Bazel clean expunge. When you're playing around with repository rules and you're trying to run Snake on Bazel, that's also going to break it. And not just Bazel sometimes. Bazel clean expunge. Some repository rules not too well written. Bazel clean expunge. Basically, the command is useless without expunge. But that correctness makes the interactive use much, much better. Oh, oof, yeah.
Another question.
Good.
When you run Bazel clean, find a bug against the Bazel team.
Yes. Would you like to say something against that? I think you're encouraging.
It should be built into the command. It should automatically find a bug.
I really love.
Will I send you the issue that I opened, and then like 3 years later, it was like, yeah, this is the thing.
This is how it works.
Basically an expunge. I will find this thing.
There's some beef going on. Well, so it's funny to notice that Ulf was not suggesting that when he was in the Bazel team.
A few years too late.
Yes, now it's your problem. But there's something worse than Bazel clean. Something that all build systems have, even Bazel, sadly. Stamping. Stamping is the bane of my existence as a development experience engineer. It's a mistake. But basically, what is stamping? Stamping is adding build informations into your build artifacts, like the git origin commit or the timestamp of your build. Now, I've mentioned initially that ephemeral informations like, I don't know, the timestamp in the action environment will cause the build to lose the action cache. You basically have different action keys every single time. This is remarkably good at doing that job and ruining your cache. So understand what stamping means and how it interacts with your build. And usually stamping in Bazel happens through something called the workspace status command, which generates under the hood a file with a key value set of all the properties that you injected. And some rules may use it. Some rules may use it in interesting ways, like the Java binary rule. And we're going to cover that in a bit, because I'm not finished with stamping after this slide. I'm going to keep hitting at it. But if you can, try not to stamp builds. So unless it's a production build, why would you even stamp it? What's the point? Do not stamp it. If it's a development build, do not stamp it. If it's an interactive build, definitely don't stamp it. If you're just running tests, why are you even trying to stamp it? Unless you have some rules that kind of force stamping because they've been written in a way to always have to stamp. In which case, my suggestion is just mock the workspace status command. Use Bazel RC to provide a different command to workspace status that always outputs the same values for those keys. So you do get kind of a stamping, but it's stable at build time. Now, some rules, like Java binary, actually support this out of the box. So there is an attribute where you can set 1, -1, and 0. I only remember what one of them does and don't remember which one it is. But it allows you to inject build time stable workspace status. So read the docs, because I haven't. And if I have, I forgot that. Questions?
Why is the same number of coyotes as the migrator verbal environment?
Ha! Both of them, yes. Because this is evil to find. No, it just involves insanity, and a lot of hours spent finding that problem. Sometimes it's really sneaky to find, but you should usually have an idea of where that is. And when you have that idea, it's either fix the problem in the build, or if it's just a case of having stamping enabled on every single build, then just change either your Bazel RC file not to stamp on every single build, or edit the command line or the wrapper, depending on your environment. So it's hard to give an obvious suggestion on how to fix this, and you're gonna need to investigate a few things. It's not for coyotes, it's still a bit nasty.
Not a question, just more of a comment that a lot of the items here basically have to do with your action cache should work.
Yes.
You should have usually a very high percentage of cached actions. Now there's an asterisk there. The asterisk is if you're keeping warm Bazel to begin with, then a lot of your actions will be locally cached. And then those that go to remote execution to begin with, like those queries, they will have a lower, therefore lower percentage by design. But if you're not doing remote action cache hits. And if you don't, that is a problem that should be investigated. And one thing I like to remark is that Bazel has some tools that allow you to debug remote caching. Like basically ask yourself the question of why is this section not remotely cached? Like what changed between this build and another build with like two different invocations? And that allows you to detect things like, oh, I was accidentally compiling the proto with something that injects a timestamp into the compiled proto. Yes, I'm not making that up. You know, some hidden things like this, like stamping,
yes.
or like my user accidentally leaked his path into the action end, or things like that.
Someone gave a spoiler.
I also comment about it. It depends on which environment are you talking about. Because if it's a CI pipeline, you use the same machine, so you can measure it better than local machine. Everybody has their own Xcode if it's Mac machine, so the cache hit ratio will be differently.
Yeah. That's why the asterisk I said. Like if you're using more Bazel, then your remote cache ratio will go down by design, and yet you still can ask some questions about it in debugging.
Yes. I do like the rule of thumb, and in general, yes. Most of them have to do with action cache, because you really don't want to repeat the work. That's one way to speed things up. You either parallelize things or do less work, right? And one way of doing less work is caching, and in this case, caching actions. So a lot of this is just about debugging that and preventing that. And in a similar vein, avoid volatile values in file paths or really anywhere else. Because if some values change during a build every single time, then you don't get action cache hits, right? Same logic, make sure that your build is stable. File paths are stable, environments are stable, and so on, right? Now, onto some really interesting things. Testing. Because Bazel does a lot of things at build time, but when it comes to testing, Bazel still does a lot of things. There is a whole talk from Wolf about Bazel testing. I think it all boils down to, you have an executable, it succeeds, test pass. It doesn't, test failed. And there's a lot of optimization that you can do when you're running the test. So, some of you are familiar with various testing frameworks, and really any of them is integrated with Bazel. And a good example of that is test containers. Now, if some of you are familiar with test containers, it's a library that allows you to run containers during a test and simulate very complex setups without having to manually write your stubs. Like, let's say I want to run MySQL in a test, because microservices are basically a database with some queries on it. I'm gonna have to either stop that database and add a lot of complexity to my test, or use that library which provides it out of the box. Now, if I'm running this remotely, that library will automatically download the container image every single time it's in a new worker, every single time you do it on a different image, and so it does not, for example, use any of the caching facilities that Bazel has. What I suggest in that case instead is try to let the build system handle this. Try to use, for example, in this case, rules docker to download the image tarball and just load that in the test, instead of just providing the image at the end, letting test containers download it. So you get cache hits remotely, and the remote execution environment is going to be able to share those images without having to pull them from Docker Hub, for example. And this will make your test much, much faster. I only gave it 2 because it might make things faster, but when it does, they could be much, much faster. It's also 3 coyotes because it's not trivial. You have to look into your code base, find out how your tests work, and then fix them, potentially one by one. Or if there is a common entry point in some framework, that might be easier, but it's still not trivial.
Also, you need to somehow patch up. At least we needed to bring the tar. There is a whole song and dance about doing the repository rule such that I bring the image and then I load it up and then I feed it to the specific test and whatever. So yeah, it's not easy, and it's easy to get people to do the wrong thing. So
Yeah, it sounds like one of those stories that last 8 seasons and end up in a complete disaster.
But it's super important, I agree.
Yes, it is super powerful, and it is extremely hard. And you might not find out how good it is until the end. So it is a big investment, I acknowledge that, but it can make things much, much faster. Another easy to achieve things, which is not going to make things much, much faster, but will make them easier to manage later on, is split test targets, byte speed, flakiness, and other characteristics. So for example, Weeks mentioned that one of the problems were unit tests in disguise. Now, if those unit tests were in an integration test or end-to-end package, it would have been easier to categorize them and handle them differently, like injecting different exec properties, marking them as flaky, because they're integration tests. But because the organization was not perfect, in that case it was hard to find what those tests were. And so they eventually became technical debt and caused a slowdown. So it's not an immediate thing that organizing things makes your build faster, but it will pay off in some time because it will allow you to more easily find where the bottlenecks are and fix them. And the really cool feature is test sharding, which is run a test, a slow test, a bunch of times, the fastest one wins. Now, you don't want to do that to, I oversimplified, please don't look too much at me. But if you run it a bunch of times, you're going to consume more resources for a single test, so there are some trade-offs in here. But if it's a really, really slow test, and there's going to be a few of those in a large code base, if you raise them, then one of them might be slightly faster and speed up the overall build. So use it sparingly, but this is a really powerful tool.
Especially maybe for tests that have a high variance.
Exactly, especially for those tests. Let's say that your test contacts the network, so calls home, and does a lot of networking stuff, which it really shouldn't. I check your test before you do that. In that case, one of those tests might actually be wickedly fast, whereas the others would be extremely slow. Now, it's usually sheer luck if you run it once, if you're going to get a fast test or a slow test, but if you run it multiple times, it's sheer luck divided by that number.
So, test sharding, you're saying that it's the same test, I run it a few times in parallel?
Yes.
Isn't test sharding like when I have 20 tests in my target, and now I want to get like 4. Okay, so okay.
I got it wrong.
Yeah, there's a bit of confusion. So sharding is when you take a test target and you break it up into, say, 2 or 3 pieces, and if you have 3 test methods, then you can run one method of one shard, one method of the second, and the third one. What I think Itai is asking about is runs per test. When
yes,
I
think this is what he meant, like runs per test, which is like you're saying, okay, like hopefully, let's spray this, and 1 out of the 4 will pass, so my build will test. By the way, unfortunately, we also run with that, like at Wix, because our ITs are flaky, so like let's do runs per test 3 and pray to God that the build will not fail.
Oh, thanks for the suggestion.
But let's pray these days.
You sure? And as for the last, now we're on to the last suggestion. And I want to leave this last suggestion with a message. Yes, we're going to look at this tool. I'm going to explain what it does. But my suggestion and my hope for the future of Bazel is that we, as a community, can try to write automated tools which are focused on user experience and simplify Bazel, because Bazel really doesn't have to be so hard on users. Bazel could be much, much more intuitive. A good example of this is the analyzer at EngFlow.com that we wrote at EngFlow, which is automatic personalized suggestion for faster Bazel builds and tests. At github.com, EngFlow, Bazel invocation analyzer, all underscores. Please start our project. We want more stars. Please. And what this project does, it's either a UI or a CLI. It comes in both shapes, even a library if you want, if you're fencing. And you feed it a profile, which is this big JSON that Bazel produces that we've already used to analyze our performance improvements, and it automatically outputs suggestions, which could be either break down bottleneck targets or increase the memory you give to Bazel, and other kinds of things. One of them is even use remote execution, EngFlow. So please give this a go, analyzer.engflow.com, and feel free to contribute because it is an open source project. Once again, I really want to encourage the community to come up together, create more tools, make them open source and available to everyone. Because it does not have to be so hard to work with a build system that makes your life much, much better. That's all, folks. I wanted to ask any questions, but go ahead.
Tip number 14. Do not download intermediate artifacts. That's a wonderful, wonderful feature that was implemented in Bazel.
Yes.
There are asterisks involved. Basically, the idea is, for anyone unfamiliar, is that when you're executing a build, you need to execute one action that depends on another action, that depends on another action. And what Bazel would normally do is download all the results of the cached, remotely cached action A, then ask the remote cache, hey, do you happen to have action B cached? Yes. Oh, okay, let me download all the results of this. Hey, do you happen to have action C cached? This is not necessary. Obviously, you could ideally not download anything ever except for the final binary, or if you're running a test, you don't even need that.
Yes.
Right?
How is it called? How is it called?
So I know of like experimental remote download minimal, something like that.
It's called build without the bytes.
Yes. That's
by the way, for us it was a dramatic change. Like a dramatic, it was a huge speed up in our build.
Yeah, and that is in my experience true of any build system that migrates to remote execution. Because you have, as I noted, 95% remote cache, right? And then whereas the time spent,
Yeah, I was going to say.
And you don't care. You don't care because like the machine itself doesn't need the output. And you need it from the source code.
Yeah, so the only asterisk about that is that you may run into a problem if you need to rerun some action if the results actually disappear from the cache. But fortunately, with EngFlow, that should not happen.
Flag referencing. It's remote endless scroll.
I know, I remember the flag. I don't remember how to find it.
Command line reference.
By the way, you can ask this stuff to ChatGPT, yeah? Just mentioning it.
Antonio, are you running a demo of the analyzer?
Do we have a profile? Envoy? Do you have a profile you can share? Yes? Make sure not to share.
Make sure it's shareable, yeah?
I know it's your problem. That's fine, it's your problem now. There you go.
I'll just set up the analyzer and you could explain about it.
That might have much harder now. Never.
I think while you're setting this up, I can mention one more tip, which is using the disk cache.
Yes.
Which is basically a remote cache, but locally. So you get this caching across your workspaces for free, even without paying for EngFlow or other products.
Boo.
But even when using RDE from EngFlow or other providers, it helps you to cut down the network cost.
So for the disk cache, it used to be a slide, thanks to Laszlo. But then we looked at the source code, and we found that it was actually like automatically set up if you don't do anything.
That's not true.
Okay. So we removed the suggestion. Was it repository cache?
Is set up automatically.
Yes. So we removed the slide for no reason. That's great.
Repository cache. That's also awesome. The locally caches all the downloaded repositories.
Now, one of the latest things, like you can use remote and disk, right? It was smoother for a few years, but now you can do.
Yeah, I think since 5 point something you can combine those two.
So this is amazing also.
Okay, yeah. He's already uploaded the profile because he's still fast. And okay, my first suggestion is just increase the value of minus jobs. You can run more things in parallel for this specific build based on the profile. And we explain why that is the case. We link you to the documentation. We give you a rationale. Breakdown bottleneck section. So we found some targets. They are like not executing too much in parallel. There is a bottleneck in that section of the build. We're telling you, hey, those targets are this, and this. Break them down if possible. And this is the improvement that you get. With some caveats. As in, we've only showed you a bunch of those actions and targets, because there were way more of them. Build without the bytes, see? We got this. Disable merged events. This just means we wanted more information during this profile analysis. If we enable this flag, we're gonna get them. And contact EngFlow.
Slick.
Yes. Please reach out to Alan. That's it.